Okay, so I think that we are live. So thank you very much for joining. So this new episode of our virtual meetup, Ticino virtual meetup. So here with me, Giovanni, there are Giancarlo, Marco, and our guest star Mario. Okay. So thank you very much for all of
Hello.
you. Thank you, Mario.
Hello.
So
Hello.
okay, so before start, I'll give you some short introduction to our group, and after that, I will leave the word to Mario. Okay, so okay, our group is called Ticino Software Craft. So why Ticino? Because mostly all these people that you see in this slide are people that are organized a meetup in Switzerland, in Ticino. So, and they meet each other at the beginning of this group when is created this group in lastminute.com. Okay, and now they are still together as a group of professionals. Okay, and why we decided to call us Software Craft? Because I mean the main reason is that we are inspired by Software Craftsmanship Manifesto, and in the Software Craftsmanship Manifesto there is a point in which speaks about to build a community of professional. So this is the reason why we are here today and why we created this community. So because we are guided by the need to raise the bar on technology side, on methodology side, and as a professional, software professionals. Okay, so these are our channels, and usually we spread the word about our talks and our stuff with the meetup.com, but we are also using other channels like LinkedIn, Twitter, and so on. So please follow us. And please give us feedbacks about talks, about other what we are doing. So in order to improve our content, our activities. So that's all for me. So I leave the stage to Mario and his talk about data, dealing with data consistency and mostly on Debezium.
So I think that we can start and welcome all and thanks for joining this talk. Today I will talk about data consistency and change data capture pattern. So this is the agenda. So we will start understanding the problem, and then we will see what change data capture is, and then I will talk about the Debezium and how it can help us with our solution, and finally I will show you a quick demo and some takeaway. But before starting, let me just spend a few words to present myself. I'm Mario, and I'm a senior software engineer at Red Hat, where I currently work on the Debezium project. I'm fascinated about open source, and during the last years, I also contributed to other open source projects. So if you want to reach me, you can take a look to my website, where you can find my contact information. But now let's start with our problem. So we have a product service, and then we that store its information, so product information, inside the database. But at a certain point, we want to store this information also in a search engine, because we want, for example, enable full text search in our e-commerce site. And so how we can do that? We will go through different solution. This is the first one, that is the easiest one, and with this solution we not only write on the database, but also let our product services to write on a search index. But this way we are using a solution that is called dual writes. Okay, and with this solution it's easy to implement, and there is no specific setup or installation required, because we just need to write on another external system. But this solution has a big cons, that is that data can be inconsistent. This because this operation cannot be atomic due to the fact that we cannot rely on the database transaction, since we are writing on two different systems. And usually the things can go wrong independently in this case. And remember that anything that can go wrong will go wrong. And usually this happens during the nights and the weekends. So before to go to the next solution that is based on the change data capture pattern, I want to give you just the definition. Sorry, the definition about the change data capture. I take this definition from the Wikipedia, and it say that it's in database, change data capture, CDC, is a set of software design pattern used to determine and track the data that has changes, also known as deltas, so that action can be taken using the changed data. So the next solution, okay, permits to use the pattern of CDC. In this case, the approach with the query-based approach. In this case, we can also call this approach batch processing. So in this case, what we are doing is create a scheduled job that get the data on the database and then move this data to Elasticsearch Index. Okay. And with this solution, with this solution, um, we need to set up just a scheduled job that does some query on the database. So there is no there is no lot of cost compared with the other solution. But the cons of this solution that solves the problem of the dual writes have other issues that are, for example, with this solution, we cannot get the deletes from the database, because this requires us to do some diff mechanism to understand if some row has been deleted from database. And also we don't have no old record state about the record, because we just query the database and get the current state of the record. And also this solution requires a checkpoint mechanism. So you need to understand where the last run of the job arrived to proceed with the query of the data. So if even if this solution is a little bit better respect to the other one, we have some problem to solve. Sorry. Okay. So with this other solution, we have a log-based approach. So it's a more even stream solution where, in this case, we are going to capture the changes that happen on the DB logs. So every database have a DB log, and each database have a different name. For example, transaction log, write-ahead log, redo log, and many others. But the concept is the same. When you write a statement in the database, this operation will be firstly saved in this log for maintaining the ACID property, and then the actual data will be stored on the file. And with this solution, we will go to listen on this file and move these changes on a message queue. In this particular example, as you can see, in the queue we have a C event. That means that we have captured a create statement on the database. And also we have an update event. That this means that we have captured an update, and also we have a D. That means that we have captured a delete event. So also with this solution, we have no impact on the current application since we are just listening on the database log, and we are able to capture also delete and all the record status because we have all the history of the operation that has been done in the database. And also with this approach, we have a more real-time solution because instead to do a continuous query polling the database to get the new data, we are just reacting fast on the changes. The only cons of this is that we need to set up our database to enable CDC, and so we need also a tool that permits to read this database. And here is where Debezium comes to the rescue. Debezium is an open source log-based CDC solution that permits to stream your data changes from different databases in an easy way. It's sponsored by Red Hat and also supported by a very large and active community, and also used in production from different companies like Shopify, Ubisoft, Vimeo, and many others. But we saw in the previous example that for the log-based CDC, we are going to get data from the DB log, but maybe not all of us know which type of information is present in this DB log. So I want to show, for example, this is an example of what can be found inside a transaction log of a Postgres database. In this example, in the picture above, there is the statement that we are doing on the database. So in this case, we are inserting two row inside the data table inside a transaction. How this is reflected on the log? In the picture below, we can see what information is stored in the transaction log of Postgres. So we have three information: the location, the XID, and the data. The location is just a sequence number that is called log sequence number. Instead, the XID is the transaction ID. And as you can see in this example, we have that all these statements have the same XID because we executed the true insert inside the same transaction. So this is usually the information that are present, and for the insert statement, you can see that there is information about the data, the type of operation, in this case the insert, and information about the column, the type of the column, and the data that we inserted with the statement. But we have shown that Debezium move this data inside the queue. And this is how a message inside produced by Debezium appears. So we will have inside inside the Debezium data change event two main objects: the message key, that usually is the table primary key, and then we have the message value that contain, first of all, the data that comes from our database. In this case, we have two parts, the after and the before, because in this case, we are using, this is an update event. So we have the before part, that is the status of the row before the update. And then we have the after part, that is the status of the row after the update. And then we have also other information. For example, inside the source object, we have information about the version of the Debezium, the type of the connector that we are using, in this case Postgres, the name that we give to the connector, and also information about the DB, the schema, the table, the transaction ID, and also the log sequence number that we have seen in the previous slides. But also we have the information about the type of the operation. In this case, this is an update, but we can have also the delete and the create information. An important note, as you can see here, we have two timestamps. The timestamp inside the source is the timestamp when the change happened on the database. Instead, the other timestamp is the timestamp when Debezium processed the transaction log, this event on the transaction log. So you can have also a way to have calculate a lag on the processing. And as you can see in this example, the message format is JSON, but we have also support for Evro and other type of serialization. Debezium is available in different flavors. So you can use Debezium as a sync connector for Kafka Connect ecosystem, or you can use the Debezium server that is a standalone Quarkus application where you can decide where to send your change event. For example, as of now, we support sync like Kinesis, Google Pub Subscribe, Pulsar, Redis, and many others. And also these can be extended with the custom sync implementation. An important note with the last releases, we have also released our Kubernetes operator, so you can easily deploy on Kubernetes or OpenShift cluster in a more easy way. And last but not least, we have also the Debezium engine that is a Java library that you can embed in your application and so receive the change events on a simple Java callback, Java listener. But now let's play with the demo. So if you want, you can scan the QR code that points to GitHub repository that I will use for the demo. So if you want to play with it after the talk, you are welcome. So let me stop the presentation and move to the code now. Okay. So here is what we want to achieve today. So we want to move data from MySQL database, okay, the product data, to an Elasticsearch index. And we are doing in this way, we are using the Kafka Connect connector in this example. So you will have our Debezium connector for MySQL and also Elasticsearch connector. For ones that does know how Kafka Connect work, Kafka Connect is an API that is built on top of the Kafka ecosystem. So you need to have a Kafka cluster, then you can enable Kafka Connect and deploy your connector. In this case, we have the Debezium connector and Elasticsearch connector. Mainly in Kafka Connect, there are two types of connector. The one is a source, so it's connector that attaches to a source and put data inside Kafka topic, and the other one are sync, so take data from the topic and put data on another resource. In this case, Debezium is a source connector, and Elasticsearch connector is a sync connector. To run all these components, I have prepared a Docker Compose file. So in this case, we have the Zookeeper for the Kafka, we have the Kafka itself, and then we have MySQL. This is our example MySQL with some pre-populated data. Then we have the Elasticsearch image, and then we have the Connect image. The Connect image is built by this Docker file, but it's just our Connect image that we have with our connector built-in, and we have just added the connector for the Elasticsearch. So let's start our components. We are telling that we want to use the components of version 2.4. So let's start it. Let's see if all is up and running. Okay, seems that all is up and running. And then we want now to proceed with registering the connector. So once we have deployed the connector in the Kafka library where Kafka expect to find the connector, there is some API exposed by Kafka Connect to register a connector. In this case, we want to register this connector, and the connector configuration is a JSON file. So let's see how this connector is described. This is the classical structure of a connector descriptor. In this case, you have a name, so you are telling that your connector has this name. Then we have a configuration. There are properties that are common for all connectors that comes from the Connect API. In this case, you are telling which is the connector class that need to use for this connector. In this case, the Elasticsearch Sync connector from Confluent. Then the max task, the number of tasks that you want to provide for this connector instance. And then there are some properties that are specific for the connector, in this case, the topics, where you want to read the data, the connection rule for the Elasticsearch, and then there are another properties that are common for a connector that are the transformation. So you can define some transformation class that can be also customized to process the single message. And the transformation happens in different way, depends on if it's a source connector or a sync connector. For the source connector, the transformation happens when your connector send the data. Before sending the data to the topic, the transformation will be executed, and then the data will be moved into topic.
Mario,
Yeah.
uh, well, you can increase just a little bit the font because somebody asked for this, and
Yes. I'm see where is the. It's better.
probably just a little bit.
Where is no?
It's okay.
Okay. And so instead, the transformation on the sync will be applied when before the connector receive the message from Kafka, will be applied the transformation and then pass it to the connector. In this case, since we as we see in the slide, the message composed by the Debezium is complex, but we want just to have the section where there are the data from the record of the database. So we use this transformation that simply extract this information. So let's now register the connector. Let me go up. So I'm going to register it. Okay, this has been created. And then we want to register also the other connector. But before to register, I want to show how it's made. This is the source connector, so the connector that attached the database log and put the data inside the topic. In this case, we have called the inventory connector because we have an inventory database with the products, customer, and so on. We are using the MySQL connector from Debezium. And then we are telling that the topic generated that usually has the database name and the table name will be prefixed by this prefix. Then we are giving the information for the connection, and then we are saying, okay, we want just to take the information from the inventory database, or you can, we have also property to define specific table and other type of filtering. In this case, we are just saying, we are using another transformation that say, okay, since the topic we have this form, so the prefix, the schema, and the table, we want just to take the table. So all the data in this case will be produced in a topic that is the name of the table. So let's go and register the source connector. Okay, it's been created. And now we can go on the Docker we can go on the, let's see, the MySQL. Let's see, this is what we have inside our product table. And now let's see that we should already have this data inside our, sorry, inside our Elasticsearch. As you can see, we have the same data that are indexed in our Elasticsearch instance. Why this happened? This because Debezium has a mechanism that is called a snapshot. So when you run the first time Debezium, usually the default configuration is to take a snapshot. Snapshot means that you go on the database and query all the table or the table that you define and in the configuration and take all data and put this data on the topic. This is why the transaction log can have a retention. And so when you start the Debezium for the first time, maybe you don't have all the changes in your transaction log. And so to take the whole current status, we are doing this snapshot. So all this data that we are now seeing in Elasticsearch comes from this snapshot. This is the initial snapshot. But now Debezium is in streaming mode. So after the snapshot, we are in listening mode and listening on the change from the transaction log. So now let's go inside our database and go to insert a new product that is our Magic Keyboard. So we have inserted, and now we can go on the Elasticsearch and see that we have in real time already indexed this product on our Elasticsearch. But now we saw that our keyboard is a very beautiful keyword. So we want to update the description of our product. So we run an update, and then again, let's see on the Elasticsearch index, and here we are. This is already updated without doing nothing. And then finally, we want to delete the keyboard because we want to be the only one that have this keyword. So we delete the keyword from our product, and immediately we have removed it also from our Elasticsearch. Okay, so this is, I think, all that I have for demo. Yeah, okay, I will leave it up eventually for question after, but let's come back again to the slides. I'm going to conclude, and this is just some takeaway. So today we have saw that CDC can be a very useful partner to enable streaming your data changes. It can also solve other use cases like the caching validation, auditing, data migration, and also it can help the implementation of famous pattern like outbox pattern or strangler fig pattern. And also we have seen how Debezium can help since it implemented the CDC pattern for the main database, like we have as of now support for Oracle, SQL Server, MongoDB, Postgres, MySQL, DB2, and there are other databases that are in incubating state. And so I think that's all from my side. So I'm opening to the question. But before answering question, I want to give you some call to action. So as I said, Debezium is an open source software, so contributions are always welcome. So if you are interested, don't hesitate to contact me. And finally, if you want, please dedicate just 2 minutes to give me a feedback that it can help me a lot to improve. So thanks again.
Thank you, Mario. Thank you very much. It was really interesting. And also we have some questions that were sparked by your fantastic presentation. I will start from the first one, from Marco, actually. It is, in your experience, is better to use a view in order to use for making a CDC? I was thinking about association tables. I don't want to have aggregation logic in the application and in Kafka consumer side.
Well, usually we suggest to have the aggregation on the consumer side, like using, for example, I just see a name, Apache Flink, that permits you to easily process the logs and do all the aggregation that you need. Because, but if you want, you can also use some information about the view. So it's
Yeah, because well, my concern is well, in the application I have the logic that is creating the aggregation, no? And if I spread just the tables through my connectors, I have to reuse or reimplement the same aggregation logic even in the consumer part, no? That's my concern. And that's why I don't know if it's better to use a view or because it's the same logic, no? I
yeah,
mean,
yeah.
I'm imagining some association table or anagraphic table that are joined and stuff like this, no? I want
Yeah.
just to
Yeah. Currently, I don't remember if the view information are captured by the different database, but maybe I can give you the answer in a separate session, because I need to understand. I don't remember if there are the possibility to get information from the view. Maybe depends on the different database, but I will check. Thank you for the question.
you're welcome.
Okay, moving on, just a small feedback for later. This last QR code looks like it is disabled, they reported. So, okay, later on, maybe you can
You can give us the link. We can put it in the comments, Mario.
Yeah, I will try to find the link. Yeah, I can put it in the comment. Thank you.
Oh, thank you. And so the next question is from Chicho, and it is, how does Debezium detect when something is happening on the source database? Through the connector?
Yeah, the connector has this behavior. So this is the role of the connector. The Debezium connector, we have different connectors for every database, because every database has its own way to access to the blog. For example, Postgres has a dedicated plugin that is called logical plugin. They call the logical plugin that permits you to get this information from the log. There is MySQL that has a client to interact with the bin log. So depends on the other database, the Debezium uses the way to connect to this information and then parse this information and process it and put on the topic.
Okay, clear, thank you. And related to connectors, again from Marco, what happens if the Kafka connector is down? When it is available, it will reconcile all the changes?
Yeah, if you are using the deploying the Debezium with the connector, you rely on the Kafka Connect ecosystem. So if your connector is running on a particular node and this node go down, this will be rescheduled on another node. And so it will start from where it stopped, because there is a mechanism to saving the offset where I arrived in the log. So constantly this will be saved to the Kafka, and then if the connector will restart, we restart exactly from the event. We have also at least once delivery. So you can have some duplicates in case of bad failure, but we will not lose event. Also because take in mind that the events are already in transaction log and are persisted until you have some aggressive retention policy on this transaction log. So for example, if you have a retention of 1 day and your connector stay down for 2 days, you are losing some events.
Okay, thank you. Skipping for a second a question, because I saw a couple of questions that can be clustered together that are about snapshot. So the first one is from Vincenzo, that is asking, how does the initial snapshot work? Is it a process that could wait and load our production DB with massive queries, or is it based on the transaction log as well? And also Fabrizio asks, can I filter the data will belong to the first snapshot? Maybe I don't want to ingest all 10 years DB. So the first one was about the initial snapshot.
Yeah, the initial snapshot get the data from the database, so do some query on the database. There are some quick lock on to capture the current schema of the tables, and then there are processes that continuously do the query to get the data. So can be an EV process if you have a bigger table, but there is also a way to speed up with some parallelization, but it's something that you should do once a time, just for the first step to get. But if you are not interested in the history of your data and just want to start doing and getting the current events, you can just skip this snapshot. And related to the other question, can I filter the data? Yeah, you can also filter the data, even if with the snapshot you can put some overrides of the query that we usually do to use your query to select the data.
Clear, very clear, thank you. Then going back to the question that I skipped from Tiziano, is it the order of the operations in a transaction guaranteed, and how?
I don't. If I understood well, the order in transaction log is a guarantee because the transaction log is processed sequentially. So we cannot process it in parallel. So we have to process it in a sequential way. And so the order that are in the transaction log are kept also in the topic.
Got it, thank you. If Tiziano meant something else, please write a comment. Or Mario Pio is asking, can it be used for outbox pattern? But I think that maybe you already mentioned it.
Yeah, for sure you can use it for outbox pattern. That is you can, for example, create the outbox table, and so write on your table, and then inside the same transaction write on the outbox and point the Debezium to the outbox table and put automatically the event on a topic. And also we have, if I remember well, also an extension for Quarkus that does this automatically together with Hibernate, if I remember well. And also another particular thing, for Postgres, you can have a way to write directly in the transaction log without having the outbox table. So inside your transaction, you write the data on your table, and instead to write on another table, you can just simply emit an event on the transaction log. So to avoid to have also the outbox table.
Very interesting. Since we were talking about a use case, outbox pattern, I'm trying to clusterize a couple of questions from Mark and Mario Pio. It is about use cases. If you have a real example of the usage in your experience, or if you know which are the most frequent use cases for which you can use this kind of technique.
Yeah, the most cases is the one that I highlighted. The one is, for example, this one to update Elasticsearch indexes, or the caching validation that are quite used. And also someone are using it for data migration, migrating to database or feed data lakes. So there is a lot of useful stuff, but the majority of the user start using Debezium to enable to start going in the event streaming world. So once you have this streaming enabled, you can do other stuff like event processing with Flink and and many other stuff. Also, the auditing is something that is used.
Yeah, thank you. I leave the stage for a moment to
Yes.
the other one, because
Yes.
I have one person at the
Yeah,
door.
don't worry, junk. Okay. So
Okay. See you in a
okay.
minute. Thank you.
Okay, so thank you, Mario, for the answer. So maybe we can go ahead for the question that are really interesting. So I think that maybe we can another one from Ciccio. We can see another one from Ciccio. Won't filtering the data impact negatively with the snapshot? I mean, snapshot plus transaction log should ensure that the status is kept. If you filter data, how does it work to guarantee the state?
Yeah, this depends on your use case, because if you want to filter because you need to just grab some information from the history, your comment, but usually the standard approach is to take the current status of the database, and then from this state start to do the streaming of the event. I don't know if I answered the question.
Okay, Ciccio will get us a feedback about that. Okay, there is also Tiziano. Again, I think another reply about the previous question. So, and the order of different operation is guaranteed. As far as I know, Kafka doesn't provide it out of the box. Does Debezium add this functionality? Ha! And now?
Well, the operation, if you have some operation on the same record, for example, insert, then an update, and delete, and again an insert, all these operations in the transaction logs are in this order.
Okay.
Okay.
Yes.
And so when these data are moved to the Kafka topic, they are inserted in the same order.
Maybe are using the same index in order to be in the same order. So in order to be on the same, because Kafka.
Also
Yes.
because if you have multiple partition, for example,
Exactly.
but the key of the message is the key of your table. So if the changes are related to the same key, it will be on the same partition, and also the order will be perceived.
Okay. Okay. I think that maybe this answered the doubts of Tiziano. So I think there is another one still, a lot of questions. So Mario, a lot of people is interested about that. So Vincenzo said, are there use cases where we need a CDC, but where the Debezium is too much, considering cost, maintenance, infrastructure? Which are the alternatives? He's going.
Well,
in
maybe
contrast.
you need to go with the query-based approach. So you need to implement your custom solution to get the data and going directly on the database and move with the data. Depends on what we need to achieve. In this case, with Debezium, it's just something that you need to set up, point to your database, and automatically have this event in your message queue. That can be Kafka or other message queue in case you are using the Debezium server. But depends on the things that you need to do.
Maybe the complaint about the Vincenzo complaint is because maybe your organization should have at least a Kafka deployed, because if you want to, to have, redundancy and all the beautiful stuff of Kafka, you should have it deployed, and it's not so easy. And it's not.
But you can have also the Debezium server. If you want, you can use the Debezium server that now with our operator, you can deploy it on a Kubernetes cluster or OpenShift, wherever you want, and so you can rely on the same mechanism. Because if the instance of your Debezium server will go down because the node will go down, it will be rescheduled by Kubernetes, so the pod will be rescheduled. So you will have the same reliability of the Kafka Connect. So
yes, because it's connected to the transaction log. So it will not lose the logs. So when it will reschedule it will be okay.
Yeah. Because remember that the fact that the change are always stored on the transaction log. So the Debezium are simply attaching to this log and get the information. If the information are still in the log, the Debezium will not lose any information. But you can lose information only if you have a very short retention period and your outage will be longer than this period.
Interesting. The availability. Okay, so if there are no other questions, I have a last one connected to the last question of Vincenzo. So, as you have talked about the Debezium server, no, in this flavor, no, with the Debezium server, if we use like Redis stream, or how much we can say that we have. Let me say, high availability is enough, is not enough, is maybe better to have Kafka Connect. How much is guaranteed? Because you said that, for example, with the Debezium server, you can reattach to transaction log. But if you put the events into a Redis stream, you know that Redis stream is not so reliable like Kafka. Is there any situation in which is guaranteed thanks to the Debezium server logics, or you have to do something handmade, you have to develop something, so about that?
Yeah, using it in Kafka ecosystem, we provide you a lot of guarantee because you have the cluster, the brokers,
Yes.
and all the stuff. You can save persist the topics and so on. So you have a lot of advantages. But you can also rely. There are a lot of users that uses also the Debezium server with other things like PubSub from Google and also other message queue that I don't remember the name from Azure. So there are a lot of stuff. In this case, you need to be sure that the thing that you use is fine for your user case, for your availability requirements, and so on. But what is assured from the Debezium is the mechanism that the offset, so that the point where we arrive at processing in the log, are kept and stored. So in the major of the case, this will be stored, and so if you connector fail and you will be able to restart it again, it will start processing again this information.
Okay, thank you for the answer. So I don't know, I think there are no other questions. So
thank you very much, Mario, for being with us. It's always a pleasure to have such a great talk.
Thank you for the invitation. And I have just put the link of the forms in the private chat. So if you can share it.
Yes, I can share it, so don't worry.
Thank you very much. And I hope that this was good also for the audience, but I guarantee that it was even the engagement that we had. And that's it, more or less. The last thing is to remember to all of you, if you want to participate to the raffle in order to have an IntelliJ license, a JetBrains license. You can, I think, fill the form.
Yes, we send a link to the form in the mail of the participants. So please check your mail in your or your spam or in your mail about the talk. So and fill the form in order to have to participate to the raffle.
Yes. That's it. Thank you again, Mario. It was really a pleasure. And
you're welcome.
I hope all of you will have a great weekend.
Okay.
Thank you, Mario.
Thank you, Mario.
Thank you.
Thank you.
Bye.
Bye.
Ciao, folks.
Bye.